PCN tours the Keystone State, taking you inside Pennsylvania's factories, museums, and historical sites.
Hello, it's a great day here at Whirley Industries. We're located here in Warren, Pennsylvania, in northwestern part of the state, adjacent to the beautiful Allegheny National Forest. My name is Lincoln Sokolsky, and I'll be your tour guide today. I'm a second-generation family member of our family business that my father, Bob Sokolsky, along with his business partner, Hal Conroe, founded back in 1960. Today, Bob and Hal are still very active in the business. What I thought I'd do is show you a little bit about our past, the products that we made back in the 70s, and then bring you up here to the present with the products that we make today. So over here on the table, you'll see some products that you may recognize. Push-button salt and pepper shakers, moo cow creamer, syrup dispenser, and so forth. These are the products that got us going back in the early 70s. And today, we are, what we like to call ourselves is, we're in the promotional drinkware business. We manufacture lots of different products from 12 ounces up to 64 ounces. On the table here, you'll see sports bottles, little kid's sipper, 12 ounces, on up through to a gallon jug. This is a jug that we make for Bill Miller Barbecue down in Texas. They sell tea in that jug. So that's one part of our product line. Then in the middle part of the table here, you'll see insulated mugs. And we've tried to focus on some Pennsylvania companies like Sheets here that we're proudly associated with. You'll recognize many of the different customers here. Newest product that we make is a 100-ounce mug. We never would have thought we'd make something this big, but this is what we call our Bubba mug. And for the people that are really thirsty, this is the mug for them. That gives you a little rundown on Whirley, and what I thought I'd do now is take you over here to our marketing section and tell you a little bit about how we go to market and the various customers that we do business with. Basically, we do business with convenience stores, theme parks, fast food, ad specialty jobbers, and hospitals. We do business with a lot of other channels, but what I just described to you makes up most of our business. And by the way, we do business in all 50 states and over 10 countries internationally. So on the theme park side, here's a pretty neat bottle that we do for Idlewild in western Pennsylvania. This is a 34-ounce insulated mug. And on the board here, we put some signage up to give you a little idea of how we go to market. When you go to Idlewild, you can buy this product for $10, filled, and then free refills the entire day. Now, that's a great value. Here's another product that we do for Dorney Park. It's this 32-ounce insulated mug right here. And as you'll see on the offer, you can get a souvenir Dorney Park mug and T-shirt for $19.95. And then you could take the mug and refill it for $2.35. Another great value. These are typical ways of how our products might be marketed in theme park channel. And you'll see down here we have Hershey Park, Dutch Wonderland. Most of the theme parks here in Pennsylvania we thought we'd put on display. We also do business with most of the theme parks throughout the country, the major theme parks, and also internationally in the UK and some other countries. Next channel of business that's really founded who we are today is a convenience store industry. And what convenience stores do is they have refill programs for coffee, fountain, frozen carbonated beverages. And so you'll see here we have Sheets mugs that they do for fountain. Here's a Wawa mug that we do. We also Country Fair, Red Apple, United Refinery. Those are all local Pennsylvania companies that we work with. But we also work with 7-Eleven, Speedway, and many of the major convenience store chains throughout the country. And I thought it'd be neat to show you what we've done for Pilot Oil. Here's two different programs that we've done. First is with this 32-ounce mug right here. You can buy this Pilot Oil mug, and inside are coupons for free Planters peanuts and 3 free refills. That's a great value for $3.19. After they did this program, they came back with our 64-ounce mug, put coupons in the mug for a free hot dog and 3 free refills for $4.99. Again, another great value. Basically, what we try to do with our products is connect it to promotions. Any company that's in the food service industry and wants to promote their business is a potential customer for Whirley. And for that matter, anybody that wants to put their name on a mug and promote their business is also a customer, but most of our business is in the food service industry. And the way we see it is if you're successful as one of our customers getting this in the hands of their consumers, this mug becomes an extension of their advertising and an extension of wherever they go. And that's what it's all about, is us promoting other people's business. Anyway, that gives you a good rundown of who we are, what markets we do, what customers that we do business with. So what I thought I'd do is show you for the tour here. This is plastic. It comes in BB pellets. Comes in by rail car. I'm going to show you that in a minute. But I'm going to show you how we take these pellets and go from there to here to make a finished product like this pilot oil mug. So if you're ready, let's go ahead and go on the rest of the tour. Okay, we found ourselves in the art department here. This is a critical step along the process of making our products, is to get the artwork correct. And in the art department here is Terry Lyle, who's been with us for 21 years. Seen many jobs go through our place. In fact, he's seen us go from cutting and pasting art off of napkins to now doing artwork in Adobe Illustrator, Macintosh computers. In this particular job here, Terry's working on a Spider-Man job for Universal Studios, and this job is going to go on one of our lunch boxes. We process 150 art jobs here a week on average, about 7,500 art jobs per year through our art department. So this gives you a good idea of how far the graphics have come from Terry from 21 years ago to what we're doing today. We can do process printing in multiple colors and gradations of shading and so forth. And I can't wait for my son to get one of these Spider-Man lunch boxes. So why don't we head over to the rest of the art department and show you how everything works there. Okay, so now that we saw how Terry did the artwork for Spider-Man, I thought we'd come into our art department here and take a look around. We have 10 artists working away on various art jobs. Over here we have Liz McClellan and Rich Pascuzzi, both long-term Whirley teammate members. Seen probably tens of thousands of art jobs go through the system over the years that they've worked here. So what happens is they do their artwork here. They do an output to a file server, and we'll go ahead and show you there how the negatives are made. So we have what I like to call the gatekeeper here, Diana Hendricks, and Diana takes all the jobs, amongst many other things. She receives the artwork coming in, makes sure that we can process it, especially the computerized artwork, and then this is Diana's machine right here, and she takes all the negatives that the jobs have been done from Rich and Liz and our other artists, takes it out, and it's all on this film here. So Diana's going to put the film in the processor, put it in this processor machine, close it up, press all the right buttons, and 20 minutes later it comes out as negatives. And over here Diana will show us the end result 20 minutes later. This is a typical negative, and Diana's got a color proof here. For all you Cal fans, you'll like this one. It's a 3-color job. There's black, gold, and blue, and what that means is we'll do a different negative for each color. This is a 3-color job. There's three negatives. If it was a 5-color job, there would be 5 negatives. So from here, we're going to go through the rest of the process. And over in Harmer Street, we're going to show you how we make from the negatives the printing plates that go onto the printing machines to then put the imprint onto the mug itself. So now we're going to head on over to our engineering department and show you how we do product development. Okay, you've seen how we do the artwork, and now we're in the engineering department. And in this department, we design our new products, we re-engineer new products when there needs to be changes. Right here, we're working on a new handle that's going to find its way on some of our products. We call it the R handle. This is John Downey, who's been a Whirley teammate with us for 34 years. probably has designed more plastic molds than maybe any living human being, certainly that I know. In fact, I like to think of John as a black belt in engineering, a 6th-degree black belt in model making and tool design. So here, John's got the design on paper, and then what he does is when he's satisfied, he sends the design over to some younger engineers that put it into the computer and do their work, and I'm going to take you back there and show you how that's done. Many different samples of different mugs and products that we've worked on, and in the back part of the engineering here we have Mark, who's been with us for 13 years designing a part. Hey Mark. Dwayne here has been with us 11 years and designing one of our mugs, and in this corner is Ruth McClellan, and she's got on a computer screen a new mug that we're designing, and she's got a new SolidWorks program that shows how you can see the product in three-dimensional. She can cut and dissect the product. She can show you just what the lid looks like or the handle. There's all different ways of using this new software technology to help us go to market faster, interface with the tool makers better, to make sure that the parts that we design turn out to be exactly the parts that we want them to be, and get it right the first time. So there's been a lot of evolution in the way computers have helped us design products better, faster, and with better quality. So this just gives you an idea with Ruth here how she can show you different ways that the new SolidWorks program is helping Whirley be a better company. Okay, you saw how we designed the parts with the SolidWorks program in the engineering department, and now we're in the tool shop. We have CNC machines. This is a computer numeric control machine, and it's making a model of the mug that you saw on Ruth's computer. We usually make a model first just to make sure that the product looks right. Sometimes when you take it from a computer to the model stage, you notice that the handle might not feel quite right, the lid doesn't fit quite right, whatever, and we just want to make sure. And with here at Whirley, with these CNC machines, we can make a model in about 2 hours. The output from Ruth's computer in the engineering goes directly to this CNC machine, and in about 2 hours we're going to have a model to look at. In fact, maybe at the end of the tour we'll be able to grab the model and show you what we made here. So this is one use for the CNC machines. We have two more machines over here, and I thought I'd like to show you. We start here with a 60-pound aluminum block, and when we're done with it, this is going to be a mold to make a new Whirley product. First thing that we do is we take this and we put it in this CNC machine here, and we're going to cut it and square it up. So what do I need to do here, Ed? Hit the green, go ahead. Ed here's going to hit the green button and get it going, and then what you'll see is it's all already pre-programmed in the computer how to square up the machine. So it's going to grab the right tools and start doing its thing and cutting into the aluminum. We have to do that first so that we cut the piece to the right size to be able to fit into our tools or into our molding machines. The liquid that you see there is pretty simple. It's to keep the tool blade cooled down so it doesn't overheat, so that it stays sharp and does exact cutting. If you didn't do that, the piece would break off pretty soon, and obviously that's not a good thing. So Ed, how long would it take to square up this piece?
Probably about an hour to do all
okay.
6 edges.
So in about an hour from now, we'll have this piece all squared up and ready to go, and then from there we'll start cutting into the steel to make the right part. Now over on this machine here, we have a piece already ready to go. This is a 32-ounce sports bottle that we make, and it's 1/2 of the tool. And we have two tools that come together to make the whole part. So I'm going to hit the start button here, and you'll see down here the machine is all computer controlled, and it's going to grab the right drills to drill out the part. In this particular case, we're just making a slight modification to an existing sport bottle that we sell to theme parks and other channels like that. And we just wanted to make this midsection cut out a little bit differently to accept a new decoration method that we have that you'll see a little bit later on. So here it's just very much fine-tuning, just tweaking the part. Okay, this is a little different part of the tool shop here. In this section, we do mold maintenance. We're looking right now at part of a tool, and it's a 6-cavity tool for a 46-ounce sports bottle. There's 3 parts to the mold. There's the core, which we call the male part, which is what you're looking at now. In a minute, we'll look at the cavity, or the female part, and then there's the manifold system that controls heating up the mold and the melt flow of the plastic into the mold itself. There's different cavities, which means how many parts you make per mold. In this case, this is a 6-cavity mold, and you can see that 2, 4, 6 parts here. So we call this a 6-cavity mold. Again, this is the core piece. We're going to walk over here now and look at the cavity part. And or what I call the female. So when that mold is put together, you have the male and the female coming together, and there's air pocket in between, and wherever there is in between, that's going to make the part. Again, as you can see, this is a 6-cavity tool. We're going to make 6 parts per injection shot. Now over here, you can see it's all torn apart, so it looks a little fragmented, but this is called the manifold system. This goes on the front end of the mold, where the plastic is injected through this part right here and then dispersed into the 6 different cavities of the mold to make the 6 parts. And you can see those 6 parts. There's a feeding system of the plastic to redirect it through the manifold and into the finished tool. So that's your kind of your 101 on what a mold is like. We've just completed the tour of the bakery building, and now we're going to go to the left here into our molding facility. This is where we mold all the different plastic parts that you've so far seen on the tour. The way the plastic comes in is on these rail cars. Each rail car holds approximately 195,000 pounds of plastic. We normally have about 4 to 5 rail cars unloading at any given time, and it looks like we have 2, 4, 6 of them today. During a month, we'll go through about 6 to 7 rail cars. During the course of a year, we'll go through 75 to 85 rail cars for the entire year. The way it works is the plastic comes in the pellet forms that I showed you earlier, and it's all these rail cars are filled with the pellets, about 195,000 pounds. Through a central vacuum loader in these big silos here, and we have 5 silos, the plastic is unloaded via vacuum air from the rail car through the tubes and into the silos. They go up to the top of the silo into the little holding bins that you can see at the top there. They're called loaders. And every 1 to 2 minutes, the loader will be filled up with about 100 pounds of plastic. There's an automatic sensor that shuts off. The plastic is dumped into the silo, and then as soon as it's dumped, the sensor turns back on and starts filling up again. And this is a continuous process here at Whirley that you'll see, that on any given day you're going to see 4 to 5 or even 6 rail cars out here. So that's how the plastic gets here, and as you'll see inside, the goal is for us to have complete automation of the plastic pellets from rail car to molding machine with minimal material handling by our teammates. So this would be a good time for us to go ahead inside and see how we mold these parts. Here's the plastic already mixed with a color, and it's gravity fed down into what we call the extruder. What the extruder is a big long screw, probably 4 or 5 feet long, and it screws the plastic each cycle time, and it's pushing the plastic from the right to left direction into the mold. Now, every 24 seconds, we're making another 4 parts of product here. In this case, this is the outer shell for a 32-ounce insulated plastic mug that we make. So there, this is a typical cycle time. The parts have been ejected, the mold is closed. Now the plastic's being injected into the mold, the plastic's cooled, and 24 seconds later, the mold will open again and 4 more parts will come out. This cycle will continue for as long as we have this mold set and we're making these parts. This is a pretty neat color that we have that we call a red marble. The parts go down the conveyor and into a holding part over here, and then will be packed in a box. We have typically 1 machine operator attendant per 6 machines. So 1 person is handling the material for 6 machines throughout this facility. I've personally been in China to factories there. They have 2 people per machine. That's how much more efficient we are here in the United States with our operations, and we need to be to stay competitive with the Chinese, as everybody knows their labor is far less expensive than it is here in the United States. All right, we're on one of our 440-ton presses here, one of our larger machines. You can see how the plastic comes down through the hopper. It's been mixed just like the other machine. It's going through the extruder. The plastic is being plasticized between 350 and 400 degrees, and then is going through the mold cycle. Now this is a pretty neat machine here. We have a robot that pulls the parts out of the tool and then stacks the parts here. We're making 4 parts at a time. That means, again, it's a 4-cavity tool. And you can see how the conveyor system, once it stacks at 7 high, moves the parts along the way, and then it gets ready for the next shot of 4 parts. We're running right here on a 23.5 second cycle. So every 23.5 seconds, we're making 4 more parts. This particular part, by the way, is for our 32-ounce insulated mug. It's the outer shell portion of that product, and along the tour I'm sure we'll see this part being produced with the inner liner and the other components that make up the entire part. The robots make it real efficient because the tools can run faster, the parts are handled cleaner, they're stacked, and at the end of the line here we'll show you how we package them, again with as little material handling as possible. That's our goal here, to stay as efficient as possible and as competitive as possible in the marketplace. Okay, so after the right number of cycles, we will have completed 1 full box of product. And then the conveyor belt sends it down, and what you'll see here is it's already preformed and sized to the box. Again, we're trying to keep the material handling down to a minimum here. This is Kyle. He's a college student from Clarion State working here for the summer, and he just showed you how quickly and efficiently he's able to do the packaging for that box and then move on to the next machine. Okay, we've found ourselves in a quality control lab now. We've shown you how we make the parts injection molded, blow molded. We need to make darn sure that everything meets our high expectations and specifications. In fact, we're embarked on a process of becoming an ISO 9001-2000 company, and we're pretty far along the path. There's certain standards that we need to meet, not only to be certified with ISO, but also for our customers and our quality control. So every hour we go around to the molding machines and we take parts. Every part that's being made is collected in this basket here, brought into the quality control room, and then through this we have a series of tests to make darn sure that they meet the specs. Otherwise, we reject them. So over here we have Dave Engstrom, who's been with us for many years, a great Whirley teammate, and he's going to demonstrate a few of the tests that we do here. This particular test is checking the diameter of the product. We have certain specs that it needs to be in terms of a low number and a high number, and as long as it hits that number, then we have a happy part. Up here in the reading here, you'll see 3.373 is a reading, and the specs for this part, the low number was 3.370, the high number was 3.378, and so it meets specs, and that means that we have a happy, good part. It's really critical that we get the diameter right, because for the mugs, we put lids on them. The lids need to fit tight. Not too tight, but definitely not too loose. When our consumers are out drinking coffee and fountain products, we want to make sure that the lids don't fall off and that they don't leak. So this is a critical part of the testing procedure that we go through. So again, this is the diameter test. Another test that we have is for wall thickness. Dave's got a neat contraption here where he puts a BB inside the product, and this particular product is the outer shell for a 16-ounce coffee mug that we have. Again, there's other parts that would go into making this, so he would test the other components as well. But what do you do, Dave? A spin test here? It's a magnetic reading, and it's reading the ball there. It's recording up here onto this. We need to make sure that we have uniform wall thickness, and so it can't be any greater margin of difference of 20 thousandths of an inch. Here you could see that this is the minimum wall thickness along the way, hovering around 58 to 60, and then the max thickness, or is that the max there, is 60. The min's down here. The difference, average difference, which reads here, which I don't think the camera could pick up, but it's 11 thousandths. So again, since it fell underneath the 20 thousandths that we set as our industry standard, or our company standard, we have a happy part, and this is an acceptable part, therefore. The third part of our testing, and we do other tests, but today we're just going to focus on these three, is a coloring. As you see from the parts that we're molding there, we make many different colors, and we want to make sure that we get consistent color parts every time, because we might make a production run of 80,000 parts today, and they might be mixed with inventory of another 80,000 parts from a week ago. We want to make sure that a green part from a week ago looks exactly the same as a green part today. And we also want to make sure that the lids and the handles and all parts are consistent. So we have this fancy machine over here that we call a spectrophotometer. And it's kind of a fancy piece of equipment. And Brian here, our teammate's going to put in, he's testing blue. Puts it into the machine. It takes light images. I think it sends light through 3 times. One way or another, it records those images onto the computer here. And there's a lot fancier stuff to describe this that I'm not so adept at, but I look at one thing. I look right here, and it says pass. And if it says pass, then we have a happy blue part. If it doesn't say pass, then we would pull that run and go to the colorant and make sure that the parts are all in spec. So these 3 parts are all part of our quality control here at Whirley, these 3 tests. We've got a great team. Glad we could introduce you here to, also I just want to point the camera over here to John Snyder, the head of the team here for our quality control here in the molding. So now that we've done all the molding, we've done the quality control, we're going to head over to the Harmer Street, and we're going to see how we take these parts that we mold and how we then print, decorate, assemble, and then ship them off to the customer. Earlier in the tour, you remember we were in the art department, and Diana Hendricks showed you how we make the negatives. Along the process, the negatives end up from that building here to the plate lab. This is Pat Stanton, a longtime Whirley teammate, and she goes through a process from taking the negatives on through to making the printing plates that end up downstairs on the printing machine, so we show you how we make the parts. This is one of the steps along the way. Pat is comparing the color proof to make sure the art is all there and correct. So this is a job that we're doing here for Racetrack Petroleum, it looks like, a convenience store chain down in Atlanta, Georgia. So, by the way, again, each color proof, or each negative, is, we have 1 negative per printing plate. This is a 3-color job I see, so there'll be 3 negatives for this job. Does it look all right, Pat?
Yep,
The color all good? Okay.
everything's there.
Super.
And then I'll come over to here.
This step here, Pat's going to prepare the plates, write information on the label, put labels on each cover sheet. So this is, again, we're stepping along the process to make the printing plates so that we can print onto the mugs. Here you'll see an art number.
Cupboard number.
This is a cupboard number where we store the plates, and then this is the product, XM64 64-ounce mug. So next step along the way here, we're going to line up the negatives on PAL to line up with presses. She'll tape the negative emulation side down. So what she's doing here is she needs to make sure that the negatives are lined up exactly correctly on the plates so that when we register each color, they're in full registration and we get a good clean imprint. Once she's got it lined up right, she tapes it down so that the negatives don't move. Because from here to forward, it's registered exactly how we want it on a printing plate. This is where we burn the plates onto the image. So this machine here will take the negatives and the plates. She's going to put it into the machine here, turn on the vacuum, press down on the negative just to make sure it's down there perfectly flush on the plate. And then she's going to burn the imprint into the plate. This takes about 2 minutes long to do so.
I've got this one already burned.
So here's a plate that's already burned, and Pat's going to pull off the negative. And what you see is the image for that color. This is Texas A&M Aggies. If there's any Aggie fans out there, here's a mug for you. So now she's going to send this through and wash away all the emulsion from the plate and put it through the washer. Rollers will pull the plate through while brushes run back and forth. This takes about 3 minutes to do. And basically what it's doing, it's washing away everything that is not to be imprinted, and what's left is, again, the burned part that we burned onto the printing plate. Okay, so this is the other end of the plates being washed out. Now Pat's going to check the image and make sure that it is what it's supposed to be. Almost always, I'm sure you get it right, but on the rare occasion that it's wrong, she'll have to redo it. Now it goes into a dryer for 10 minutes and dry off the plate, and then the next step along the process here is to take the plates here from the dryer plates. They go into the post-exposure for 2 minutes to harden the image. Once the image is hardened, she's going to roll these plates. And the reason for doing that is so that they fit properly on our printing presses. And when we get down and look at the presses, this will make more sense as to why we have to roll them. Then she wraps with cover sheets and she stores until they're ready to print. Normally when Pat makes the plates here, they're going to print on that same shift or the next shift, sometime within the next 24 hours. So for this job, it's a 4-color job. Again, this looks like, is this Racetrack Petroleum or a different one? Well, at any rate, this job's 4 colors, so there's going to be 4 printing plates to go with that job. It's going to be on a 64-ounce mug, stored in B9 in the storage bin, and that's the art number. As you'll see, and we're up to art number 117,144. One of the things that you'll see downstairs when we do our printing is Whirley's the industry leader in quality printing, process printing, doing shading, photography onto images, we're the industry standard that everybody shoots for, and I'm going to prove that to you when you look at what we're doing downstairs. Saw upstairs how we make the printing plates, and now we're down on the floor to look at the actual printing press. Jeff here's been a master printer for us for many years. 12 years he's been a Whirley teammate, and I like to call him a 6th-degree black belt of printing, just like I called John Downey, our chief engineer. He's one of the best printers we have here. What you're looking at is an offset printer. This particular machine can run up to 7 colors. The job that we have set up is the same one that we looked at upstairs, which is a 3-color job. You know how we rolled the plates upstairs, and we do that because you'll see they roll onto these cylinders here. So this is one of the 3 colors. This is the finished imprint of what this product's supposed to look like. Racetrack Petroleum, come in first. And you saw this mug upstairs, or actually the color proof upstairs. Now we're getting closer to what the finished product looks like. Okay, we're inside the printing machine now. And what's happening is those printing plates are rotating onto this printing blanket so that when the image, the 3 colors hit that blanket, it makes this image here, and then that image is transferred onto the blank mug, and then the finished product's going to look like this. Before the mug gets to this point, it goes through what we call a flame treater, and that prepares the plastic to accept the ink and the ink to adhere onto the mug. So once the flame treating happens, then the mug's rotated around. It's going to hit this printing blanket. We're just going to run this machine real slow now. That's 1 pass, and that's all it takes to make the image of that mug. Okay, so now we're starting at the front of the line of this product that we're making, 64-ounce mug. You saw how we do the printing plates and everything. We thought we'd back up and start with this machine here. It's called an unscrambler. And what it's doing is we're dumping several hundred of our mugs into this hopper, and then through the conveyor system, it's lifting the mugs up the conveyor, and it's ultimately orienting each mug to prepare for printing. Again, it's a great way to minimize material handling by our teammates. So now what you'll see is through the unscrambler, the mugs are coming through here, and if they're not lined up the right way, then it'll flip them over. This one here is going to flip over right here because they're not lined up the right way. Once they get to this point, they're all lined up exactly the way they need to enter the printing machine, and then they go through the process of what we looked at inside the machine with the rotation with a printing. So here you see the mugs being ejected from the printing machine, where again we're printing about 35 parts a minute. Now they're coming through the printer onto this conveyor. Jeff, again, who's our master printer, inspects parts periodically to make sure that everything, the imprint's the way it should be, the ink's adhering, and then they drop onto this holding system here, and you'll see it's made out of rubber to soften the blow of the mugs to prevent scratching, and then the mugs stay in this holding pattern, and then our teammate over here will be taking the mugs out of here and packing them into these boxes, ready for the next step along the manufacturing process. Okay, so we walked about 15 feet over here, and now we're looking back. You can see the same machine printing the same job. All these boxes here are in the holding stage. These are a printed product of everything that we just saw, same Racetrack Petroleum job. And from these boxes, they'll load onto the assembly equipment to keep the process going along. This is a hand-fed job, and we need to make sure that we keep up with the entire line, so we try to keep it filled here. It's a gravity feed down, and so we'll walk around here, and we're going to show you the next step along the way. Here, Tony Martin is putting handles onto the product. This is called ultrasonic welding, and it's a frequency of 20,000 hertz, and with that frequency it vibrates the plastic at such a high speed and the sound that it actually fuses and melts the plastic together of the handle in the mug. This particular handle is a brand new handle we call our X handle. It's ergonomically made, designed. It's big and beefy for a big and beefy mug, and it looks cool. So you see the shuttle over here, how it's taking the mug's gravity, putting them under the mandrels here. The mandrels have a suction air vacuum to hold the mugs into place. And then again, they get to Tony here. She lines up the handles with the imprint, and then it goes along to the next stage here. What you'll see here is the ultrasonic welding in action. There's 4 horns that come down. Each horn is hitting one spot on the handle. The 4 spots that ultrasonic weld onto the mug. So the next step along the way is for the mugs to be put upside down, and then these foam liners put inside of each mug. The foam helps insulate the mugs for both hot and cold beverages. And we have 2 different ways of foaming here at Whirley. One is with these foam liners, and another is with a liquid foam that we pour into the mug, and then it goes through a heat tunnel and expands out. We found that they both insulate equally as well, but one reason why we like these foam liners better is we get a guaranteed full shot every time. It's filling up completely the air space within that mug, and therefore better insulating sometimes than the liquid foam. But both methods work very well. This is also cleaner and more efficient methods, so we like to do it for that reason as well. Once the foam liners are put into the mug, they come to the next station here where we're doing spin welding, which is different than the sonic welding on the hand with the handles. Our teammate here is putting the mugs upside down, putting the bottoms on, and as they rotate around the carousel here and get to the 180 degrees there's a welder that spins them, and the speed and the friction that's caused from the spin welding causes the plastic to melt from the bottom of the mug to the base of the mug, and it welds and melts the 2 plastics together. If you look at this bottom here now, that's on there. You cannot take that off. It's fused it into a one piece. Again, so if we just recap here, we printed the mug, we welded the handle, we turned up the mug upside down, we put the foam liner inside the mug, we've spun welded the mug, and now it continues along the process here. Comes down the conveyor belt. Our teammate here is putting on the lids onto the mug, and she's just putting them into a pre-form here, and then we have a machine that snaps them down. Right here, as they roll through the roller here along the process, every lid is being snapped down by the snapper. Again, this is a machine that Dave Klink and Keith Shaw and his guys made right here in-house at Whirley Industries. Once the lids are snapped down, they're going through the next step along the process here, and to what we call shrink wrap decoration. A lot of times the convenience stores want to have the mugs shrink wrapped to keep them clean and not to have dust collect on them. So the wrapping is being done in this process, and then they go up the conveyor belt. They go through a heat tunnel here. And at the other end, we have a shrink wrap mug ready to go to market. So we're almost there at this point. We're going to come up this conveyor here, and the mugs are being packed right into the packing box. This particular case is a 12-pack, 12 mugs per case. And as soon as we get 12 mugs going, then it's sent down the conveyor here to be taped up and ready to go. What happens here is this machine automatically tapes it, and at the same time it sprays the imprint onto the box, tells what product it is, the date that it was made, the order number, so that all happens on that same pass when they send the 12-pack through the tape machine here in Labeler. From here, you can see that we have barcode. I'm sure this is for the distribution network that they've requested that to go on the boxes so that when they get into their racetrack's distribution network, they can barcode scan them into their inventory system. So from here, they're going on to shipping pallets. And once this pallet is full, the workflow, again, as I said, goes from one end of the building to the other. So on the other side of that wall over there is our shipping warehouse. And this product will be ready to ship. It'll probably go out today or tomorrow as a complete order. All right, I've told you how we do the offset imprinting. You saw the printing plates and the racetrack job that we were doing. Now I want to show you a different form of decoration. Our teammate here is loading the product into this conveyor system here, and there's a spacer here that makes sure that the parts are spaced evenly apart. We're doing about 30 of these a minute here, and what happens is this labeling decorating equipment cuts the piece, spreads it out, and then it drops gravity fed onto the part here. It's actually pushed down onto the part. There's a little fan going here that helps to make sure it pushes the shrink decoration all the way down onto the part the way we want to do it. And as you can see, we're doing a NASCAR job. I'm sure there's a lot of NASCAR fans out there. In fact, here in Western Pennsylvania, we understand we're one of the top NASCAR fan-based markets in the country. So I myself happen to be a NASCAR fan. What happens here is the bottles then go through a heat tunnel. The heat's between 300 and 400 degrees. So as they go through the tunnel, about 10 seconds later, comes out at this end, that label has formed to the contours of the bottle. Now, as you remember back in the tool shop, I told you that we were modifying this bottle, and we found that if we made this curve just a little bit different, which is what they were doing, this label would fit better onto the bottle. So that was the purpose of working on the tool there. Here you have one very nice looking NASCAR sports bottle ready to go to some Pennsylvania NASCAR fan. At the end of the line here, we go ahead and pack straight up. This particular product nests to take up less space. So, and this is Jamie Crutchfield, by the way. We have a good idea club here at Whirley where teammates are encouraged to submit good ideas. You met, actually you didn't, but there's a G.I. John is our good idea coordinator. His full-time job is to coordinate jobs, good ideas. We get over 2,000 good ideas a year. Well, Jamie here submitted a good idea to have us on Pennsylvania Cable Network, he and his friend Kathy Carlson. So here we are, Jamie, Pennsylvania Cable Network. Jamie's packing up the bottles, putting them in the box here, and then he's got the lids pre-packed, the straws pre-packed, and he'll put those in. This is a 40 pack, so he's putting 20 lids, 20 straws into the case, and then when that's done, he'll send it down here, and they'll tape it up and label it just like the last box. Okay, no Pennsylvania PCN tour would be complete without showing you us making some mugs of a Pennsylvania company. Most of you probably are familiar with Wawa convenience stores, and here we're making one of the mugs for them, a 22-ounce coffee mug. So here we have the outer shell of Wawa coffee. Again, we're putting it onto the mandrels here, orienting the handle with the imprint that we have here. Make sure we get it right each time. It goes through the system, and then you can see the ultrasonic welder here hitting one end of the handle on the left. As it rotates around, then it hits the other side of the handle, and it's ultrasonic welded on. The plastics melt together, and you now have an outer shell of a Wawa mug with a handle welded on it. Next step along the way, it comes down this little feeder table here, and now we're doing the liners. This again is a spin welding process where we spin weld the liner onto the mug, and through the friction and the speed of the spin, it melts the outer liner of the mug to the inner liner of the mug. So Wawa is a great Whirley customer, a great Pennsylvania company we're very proud to be associated with. Okay, you've seen our facilities there. You've seen the printing machines. You've seen the lifters. You've seen all the different types of equipment that we have for production and assembly. Seems appropriate to me that you ought to see the machines that we make here. This is our production engineering department, and the machine that you're looking at here is a new handle welder for our 44-ounce mug. Outside, you saw in action when we looked at the racetrack petroleum mug being printed and assembled. That was for a 64-ounce mug. So typically in this group here, they do anything from making handle welders, spin welders, Gaylord lifters, lid snappers. We looked at all these things. Tooling for the printing manuals, all types of tooling for printing and assembly equipment. This is Frank Avellino here. He's been with us 14 years. He's doing the electrical work here for the machine. I'll pretend like I know exactly what he's doing, but the good news is he does know what he's doing. So very complex equipment. And Frank, I guess every one of those wires has a purpose, right, to make sure that the handle welder works just right, huh? All right. On the back side here, Roy Eastman's working on the machine here too. He's kind of a rookie here. He's only been here 7 years, huh? Yeah. There's a reoccurring theme here with our teammates that we have very low turnover and people stay here quite a long time. So this just gives you a flavor of the type of equipment that we make here. Again, you saw a lot of the equipment as we went through the tour there. Key component for Whirley, we're self-sufficient. We've got very smart people that know how to make ideas and turn them into reality. We do it right here in Warren, PA. Next thing we're going to do is go to the shelter workshops where we see the workers with disabilities, and they do some packaging and assembly for us, and it rounds out the complete tour. So that's next on the list. We left the Whirley facility, and now we're here at Bollinger Enterprises, so we're going to go inside and see firsthand how the workers with disabilities put the mugs together, assemble them, and pack them up and ship them off to our customer. As we talked about back at Whirley, we have 11 different shelter workshops packing our mugs and doing various job functions. And this is a typical assembly line where several workers with disabilities are putting the lids onto the mugs, snapping the mugs on the lids onto the mug, and then the mugs go down the assembly line. At the bottom of the end of the line there, we do have a lid snapper just to make sure that every lid did in fact get snapped on correctly. And then we have 5 or 6 workers putting the mugs, packaging them into the final boxes ready for shipping. As I had said earlier, this is a classic example of a win-win situation where we're able to give gainful employment to the workers with disability, let them earn a wage, give them a feeling of responsibility, and then for us it's a win too because it helps us control our workforce in terms of number of people needed, and win-win, they give us competitive pricing to help us compete in the marketplace. All right, we've been through the entire tour. We started here in the bakery building. I took you to the art department, then on to engineering, how we designed the new products. Took you into the tool shop to show you how we maintain our tools and also create new tools. By the way, I showed you that we were making a model. This is halfway done here. The other half's being made now, and then we'll glue it together, and then we'll see it and touch it and feel it and see if we've got a winner. I do think we do, by the way, so look for this new mug out in the marketplace in about 4 months. We took you over across the river to Harmer Street where the products are decorated and packaged. On this side of the river, we showed you how we go from these plastic pellets here and melt them down into a liquid form, shoot them into the injection molds to create and form products like this. We took you on the whole tour. In fact, we then took you to the shelter workshops and showed you how workers with disability are helping us out as well. That's the whole tour. I hope it sparked your interest. I hope you've had a great time. And next time you're going around town and you see a plastic mug, I hope you'll tip it upside down. And what I hope you'll see on the bottom is Whirley Industries, made in Warren, Pennsylvania.